so we're going to talk in general about series. What a series is the sum of the terms in a sequence. Okay, thank you. So if we had a sequence that looked like this, let's see, 2, 4, 6, 8. Okay, so that's our sequence. We've been talking about sequences. The series would just be adding all those up, and it would be 20. If our sequence was like 4, 8, 12, 16, ... meaning that it just keeps on going and it's an infinite sequence, then if I add all those up, I'm going to get infinity. If I have like 1/3, 1/6, 1/12, 1/24, and so on, right, then my fractions keep getting smaller and smaller and smaller. If I add all those up, I actually get 1. And we'll look at how that works when we get to the geometric series part of this. But that's the difference between your sequence and your series. So we can have the total sum of a series or partial sums. And if we have partial sums, this is a capital S, the little subscript in. So like if that was S sub 5, that means I want the sum of 5 of the terms. So this is the sum of a specified number of terms in a sequence. Okay. So if I want to find the partial sum of each given sequence, so this says S7, so I want the sum of, and if it's not, like if I just have something that says 7, I don't get to pick any 7. That means I'd want the first 7. So this is 1, 2, 3, 4, 5. That's only 5 of them, so I would need 2 more terms. But I can go ahead and do that. I'd have 2 plus 6 plus 10 plus 14 plus 18 plus, and then I'd have to have 2 more. We're going up by 4 each time, so then that would give me 22 plus 26. And once I add all those up, then the sum of the first 7 terms, I'll just give that to you. It's 98. I'm going to have you use your calculator at some point, but some of this simple, just literally adding stuff up, I will just give you the answers. Okay, let me see if they're here. Okay, so he's not here, and she is. Okay, thank you. All right. So let's look at number 2. Number 2, instead of giving us the sequence, it gives us the rule for the sequence. And I want the sum of that S5, means I want the sum of the first 5 terms. So this is n cubed, so that'd be 1 cubed plus 2 cubed plus 3 cubed, oh that's a 2, plus 4 cubed plus 5 cubed. So when I add all those up, and I'd be able to just type that in the calculator exactly like it looks, you would get 225. We just don't need to spend time punching those buttons in, since I know you're capable of it. Okay, so to understand how to find the sum, like, I know you know how to find the sum of stuff, so as long as you know what it's asking you what the notation means, then you're going to be good. So let's look at some other notation. A way to represent a series using this Greek letter. Anybody know what this Greek letter is? Sigma. Okay, it's sigma. So this is also called sigma notation. Summation notation or sigma notation works. Okay, so that's the Greek letter, the capital sigma. So here's what the little pieces of this mean. With sigma, you'll have a variable, could be n, could be r, could be whatever you want it to be. But that's equal to some number down here, and then there's some number up here. So this tells you down here, it's the first term number. The number on top is the last term number. And then whatever's right to the right of the sigma is your little formula that you're going to use. So this would be the formula for the sequence. So if I want to find the sum of this, what this is telling me is I want the sum of terms 1 through 5, and this is my little formula here, so this will be 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5, and when you add all that up, you get 30. Everybody good with that? Understand what our notation means? Okay. So here it says expand each series and evaluate. So that expand means you have to actually write it down, then you can evaluate. So we're not starting with 1 here, we're actually starting with 2 and going to 8. So that's going to give me, I substituted in here, this is going to give me 2 squared minus 2. Oh, shoot, not equal, sorry. Plus 3 squared minus 3 plus 4 squared minus 4 plus 5 squared minus 5, 6 squared minus 6 plus 7 squared minus 7 plus 8 squared minus 8. Okay, so I went from 2 to 8, substituted in there. That's the expansion of it. And then when I evaluate it, that means I find the actual value of that. So I would add that up, and that would give me 168. Okay. What questions do you have? Understand what it's asking you to do? Because what it's asking you to do is very simple. You just got to understand what it means. So let's look at number 4. If I have a number in front of my sigma, then I just treat it like a number outside of a parenthesis, basically. So this negative 9/4, I'm going to leave that negative 9/4 out there, and then I'm going to multiply it by, and I will expand this. So this goes from 1 to 6. So this would be 2 times 1 squared plus 7 plus 2 times 2 squared plus 7 plus, and finish this up. And when you're expanding, that means you substitute it in just like you see it. There's no work. Even though 1 squared is 1 and 2 squared is 4, I didn't write 1 and 4. I expanded what was there. Yes, ma'am. Uh-huh. I'm not sure 100% understand your question. I'm sorry. No, go ahead. Ask me again. Oh, like parentheses around this? Oh, I see what you're saying. How do you know that this 7 isn't something separate than this? Oh, because then it would be, you would actually have it parentheses. It would be a lot more obvious. It'd most likely be in the front. That's a very good question. So, okay, I get it now. So you're saying why, since there aren't parentheses here, how do we know the 7 actually goes with this? Because that's almost always, if I have a sigma, then everything after it goes with that. Okay, that's a very good question. Okay, So then if we, and you could do all of this in one step in the calculator, but I'm going to write it out separately so you kind of understand like why I'm even showing you that this one's different. That negative 9/4 is out front. If I actually do all this summation stuff in here, that gives me 224. And then when I multiply this times 224, that would give me negative 504. It would be fine to do it all in one step as long as your parentheses and everything were right, but it's just multiplied out front there. Okay. Any other questions? All right, so that's just series in general, okay, whether it's arithmetic, geometric, or none of the above, or whatever. But now we're specific for arithmetic series. So an arithmetic series, because sequences is what we've been talking about, all that is the sum of an arithmetic sequence. Okay, and we're going to have a formula for that. And we're going to talk about Carl Gauss today and how he actually came up with this. And I wanted to show you a little video, and I completely forgot to actually get that up and going. So I'll either show you that tomorrow or the next day and kind of explain to you where this came from. Today I'll just give it to you. So the sum of an arithmetic series, so not any, but an arithmetic series looks like this. So the sum of however many terms you're looking for, that's equal to n times the first term plus the last term over 2. So a sub 1 plus a sub n over 2. N is the number of terms. A1 is the first term. And an is the last term. So although we are talking about series, doesn't mean we're 100% done with sequences, because we're actually going to have to use our sequence formulas in here. Might not be a bad idea for you to come up with some way for you to have all your little formulas together, whatever works best for you. If it's on a separate little sheet of paper, if it's in a separate little digital document, whatever, but that way they're all there and you don't have to flip through all of your notes every single time. So this says we're going to find the indicated sum for each arithmetic series. All right, so in order for me to find the sum of the first 18 terms, I have to know n. So I do know here that n is 18. That's pretty easy for me. And I have to know the first term. All right, that's great. First term is 7. And I have to know the nth term, which means I need to know the 18th term, which I don't know. But I can figure out, I definitely don't want to write out 18 terms, but I can come up with a little equation here. The nth term difference, what's the difference here? Their common difference, 3. My common difference times n minus 1 plus the first term. That's what we did day before yesterday. So I'm going to use that to find the 18th term. Be 3 times. And that will give me 58. So now I have the first term, the last term, and n. I got everything I need, and I can find the sum of those 18 terms. That's going to be n, which is 18 times the first term plus the last term over 2. Then when I multiply that out, let's go ahead and do that one. I would have 18 times, use my little fraction, 7 plus 58 over 2, and that gives me 585. So my answer is 585. We good with that? Awesome. All right, so let's look at number 2. I want to find the sum of the first 35 terms. So n is 35. The first term is 50. I also need the 35th term, which I don't know, and I definitely don't want to write them all out, so I'll use my little formula. A sub n equals, what's the difference here? Negative 8. So it's going to be negative 8 times n minus 1 plus 50. So the 35th term is negative 8 times 35 minus 1 plus 50. And that gives me negative 222. Any questions at this point? So now that you have all of that, we have the first term, the last term, and n. Go ahead and find the sum of the first 35 terms. That's what I got. Negative 3010. Do we agree with that? Good? Okay. All right, so let's look at number 3, because this is in our sigma notation here. So the things I need to know, n, well, n, we're going from 1 to 10. I need to know the first term, which I don't know, but I can figure out, right? So I substitute in the 1. 1 times 6 is 6, plus 1 is 7. I need to know the 10th term, 10. 6 times 10 is 61. So I didn't have to come up with my little sequence formula because basically it gave me the formula. So since I have all of that, I can do the sum of those 10 terms is 10 times 7 plus 61 over 2. So that'd be 68 over 2, 34 times 10. So I get 340. Sometimes it's easier just to do it than to type all the stuff in the calculator. So number 4 is very similar to that, but we don't start with 1, we start with 4. Okay, so I know I'm going to need, the first term that I'm going to use here is actually the 4th term. So the 4th term would do 4 times 5, which is 20, minus 27 is going to be negative 7. I also need the 17th term. So 17 times 5 would be 50. 85 minus 27, so that should be 58, I believe. Double check myself there. Yes. And I need n. N, here's where I need to be careful. N is not 17. N is also not 13. Okay, because I want you to think about that. Here we went from 1 to 10. You count from 1 to 10, that's 10, right? If I just do 10 minus 1, that gives me 9, not 10. So if I subtract these, 17 minus 4, that gives me 13. I have to add 1 back. So your n in general is equal to the last number minus the first number plus 1. You have to add 1 back to it. It's different than figuring out your age from your birthday, because your whole first year of life, you're technically 0, right? You're not 1 until you're in your 2nd year of life. So that's why things seem a little bit different there. So 17 minus 4 is 13. I add 1 back and I get 14. Okay, so we got to make sure we're using the correct n numbers there. So then the sum of those 14 terms would be 14 times negative 7 plus 58. So the sum of that will be 357. Any questions at all? Okay, the only thing we're doing on number 5 is figuring out n, because I don't feel like we need to do the whole thing, but I want to make sure we understand n. What would n be on number 5? 36, yes, because it would be 38 minus 3 plus 1, so n is 36. This is the number you'd use, this is the y, okay? And then I feel like you could plug everything else in. Any questions at all? All right, let's do problems. So this says Michaela is training for a marathon. She ran 2.4 miles the first day, 2.55 miles the second day, 2.7 miles the third day. If this pattern continues, find the total distance she ran after 60 days. And if it's after 60 days, that means she's actually done it 60 times. So n is 60. The first term is 2.4 because that was her first day. I need the 60th term, which I don't know. So I need to use my little sequence formula. So a sub n is equal to, what is the common difference here? 0.15. So 0.15 times n minus 1 plus the first term, which is 2.4. So then I just find the 60th term. It's going to be 0.15 times 60 minus 1 plus 2.4. Do all that, and I'll tell you what it is. It is 11.25. It's 11.25 here. So now I have n, I have the first term, I have the last term, so I can find the sum of those 60 days. Go ahead and do that on your own. If it is an application problem, make sure you actually answer the question. Don't just put a number as your answer. And the wording of your sentence can be whatever, as long as you basically answer the question. Your wording wouldn't have to be exactly like mine. But I put, after 60 days, she had run 409.5 miles. She did that in 2 months. I probably haven't done that in my entire life. It's probably why Michaela is in much better shape than I am, and in better health. All right, any questions at all? We all good? All right, let's look at number 7. Tickets for a concert opened up for sale online. The number of people that purchased tickets in each of the first 4 minutes is shown in the table to the left. If the pattern continues and the concert venue can hold a maximum of 75,000 people, find the number of tickets left after the first 2 hours. Okay, so I know here, if this is in minutes and I have 2 hours, then what is in? 120, yes. My first term is 35. I need the 120th term, so I have to use my little sequence again. And I know it's an arithmetic sequence because the difference. So that means I can do a sub n is equal to 8 times n minus 1 plus 35. So to find the 120th minute there, be 8 times 120 minus 1 plus 35. And I would go ahead and tell you that is 987. So go ahead and find the number of tickets that are sold in the first 120 minutes. You can do that without me. So I got 61,320. Is that my answer? Even if I put it in a fancy sentence? No. Because it says, it doesn't say find the number of tickets sold, it says find the number of tickets left after that. So what do I need to do? Subtract. So I'm going to take that 75,000 that we had, subtract that 61,320, and I can say after the first 2 hours, there were, subtract them, I get 13 tickets left. What questions do we have? We all good? All right, we're not going to do number 8.